What if your car knew there was a severe traffic jam 2 miles ahead, right? Like well before you could even see the brake lights, and it just automatically flashed a custom warning symbol to the driver tailgating you.
I mean, it sounds like science fiction, right? But it's actually here.
Yeah, exactly. Today, we are looking at a vehicle that really blurs the line between a traditional mode of transport and an active, hyper-aware co-pilot. Welcome to the deep dive. We are thrilled to have you with us today as we unpack the Audi Q6 e-tron.
And, the broader context here is what I would honestly call a war on legacy compromises. Because for the last decade, automakers have largely been trying to shoehorn electric technology into frames that were, well, designed for gas engines.
Right. And it has led to a lot of awkward engineering.
Oh, definitely. A lot of weird trade-offs.
Which is exactly why we're cutting through the standard marketing jargon today. We want to see if this highly touted native EV architecture actually translates to a better daily driving experience for you.
Because that's what actually matters, right? The day-to-day.
Exactly. So to do that, we are pulling from a really diverse stack of sources today. We've got deep dive technical engineering analyses, safety testing protocols straight from Euro NCAPP, and crucially, I think real-world practical data from dealer networks.
Yeah, specifically some great data from Pool Audi over in the UK.
Right. We're looking at what the engineers claim, and we're comparing it to what actual drivers are experiencing on the road right now.
So to really understand the technology governing this vehicle, you kind of have to start with its physical bones. The foundation literally dictates the limits of the electrical systems.
Okay, let's unpack this. Because everything about the Q6 e-tron traces back to something Audi calls the Premium Platform Electric.
Right, the PPE.
Yeah, the PPE. A lot of the early electric SUVs we saw hit the market were built on modified internal combustion engine platforms. And adapting an old gas car platform for an EV is, it's a lot like trying to wear someone else's tailored suit.
That's a great way to put it.
You know, you can physically get it on, but the shoulders are tight, the sleeves are wrong, and you just can't move properly. The PCE is a bespoke architecture made strictly for this exact battery and motor technology.
Exactly. In those older adapted frames, engineers were essentially negotiating with the ghost of the internal combustion engine.
Negotiating with a ghost. I love that.
I mean, they had to wrap battery cells around structural voids left by exhaust systems and drive shafts that just no longer existed. But the PPE is a true clean sheet approach.
Because Audi and Porsche co-developed this, starting from zero.
Right. Knowing it would never, ever hold a gas tank.
Yeah.
And the immediate physical benefits in the cabin are striking. I mean, the most obvious is the total elimination of the central transmission tunnel.
Wait, that structural ridge running down the center of most cars, it's completely gone.
Completely gone. You get a totally flat floor, which instantly changes the whole utility of the cabin.
Oh, wow. Yeah, our sources note a 526-liter rear trunk. And to put that into perspective for you, you aren't just squeezing in a few grocery bags. That is enough space for like 2 large golden retrievers.
Or a family's entire luggage for a 2-week holiday, right?
Yeah.
And you don't even have to stack the bags to the roofline and block your rear view.
Yeah, and fold the seats down, and it expands to a massive 1,529 liters.
And because the motor packaging is so highly optimized, they also managed to include a 64-liter frunk.
Ah, the front trunk.
Yes, the frunk. And in the premium SUV space, having that dedicated front storage away from the main cabin is highly practical. It's perfect for storing, wet charging cables or muddy hiking boots.
Or keep the mess out of the nice interior.
Exactly. But the platform isn't just about cargo volume. It fundamentally alters the driving dynamics. The PPE utilizes a rear-biased torque distribution.
Meaning the car naturally wants to push you out of corners rather than pull you through them.
Right, which gives it a much more athletic feel.
Add in the adaptive air suspension, and you have a pretty heavy vehicle that manages its weight intelligently.
Yeah, the physical layout is essentially the enabler here. Without this specific PPE architecture, the heavy-duty electrical systems we're about to discuss just physically would not fit.
Or they'd overheat, right.
Exactly, they wouldn't operate at optimal temperatures.
Well, here's where it gets really interesting. Because this bespoke platform makes room for a high-voltage power system that operates on an 800-volt architecture.
Which is huge.
Yeah, for context, the vast majority of EVs currently on the road use 400-volt systems.
And moving from 400 volts to 800 volts is essentially all about efficiency and thermal management. Think of a 400-volt system like a 2-lane highway with a speed limit of 50.
Okay, I'm with you.
If you want to move more cars, or in this case, more electrical power, you could build more lanes. But in an EV, More lanes means thicker, heavier copper cables.
which generate massive amounts of heat.
Exactly. So jumping to an 800-volt architecture is like raising the speed limit on that highway to 100. The same amount of traffic gets through, but you don't need a massive heavy road to do it. You reduce the current, which drastically reduces the heat.
And heat is the absolute enemy of fast charging.
100%.
So because the 800-volt system keeps the temperatures in check, the Q6 e-tron can sustain a maximum DC fast charging power of 270 kilowatts.
Which is incredibly fast.
Right. On paper, charging from 10% to 80% takes just 21 minutes. You can recover up to 255 kilometers, which is about 158 miles of range in just a 10-minute stop.
Yeah.
But I actually want to push back on this a bit.
Okay, sure.
Because 21 minutes is incredibly fast for an EV, I agree. But if I'm used to a gas car, I can do a quick splash and dash at a petrol station in about 3 minutes. So 21 minutes is still a significant delay for, say, a busy professional trying to get across the country.
That's a fair point.
Yeah.
It is a delay if you view the charging process exactly the same way you view a gas pump like as a strictly operational interruption.
Right.
But if we connect this to the bigger picture, the 21-minute window is actually a highly strategic number in human factors engineering.
Oh, really? How so?
Well, it aligns perfectly with a natural highway rest stop. Think about it. By the time you park, walk into the facility, use the restroom, buy coffee, and maybe check a few emails, roughly 20 minutes have passed.
Huh. Yeah, I guess that's true.
The goal isn't to beat the 3-minute gas pump. The goal is to make the charging time overlap completely with human downtime. So the car is waiting on you
Yeah.
rather than you waiting on the car.
That is a fascinating way to frame it. And the hardware driving that efficiency is also worth a closer look, because our engineering sources specifically highlight the use of a silicon carbide or C-speed pulse inverter.
Oh yeah, silicon carbide is a massive leap forward.
Let's break that down for everyone.
Sure. So the inverter's job is to take the DC power stored in the battery and convert it into the AC power needed to actually spin the electric motors.
Right.
Traditional inverters use standard silicon, which loses a significant amount of energy as heat during that conversion process. But silicon carbide has vastly superior thermal conductivity and switching efficiency.
So less energy lost as heat means more energy is actually making it to the wheels to drive the car forward.
Exactly. It's just a much smarter way to handle the power.
And Audi has centralized a lot of these components into what they call the integrated power box, or the IPB. It takes the onboard AC charger and the DC-DC converter, which, steps down the high voltage from the battery to run normal 12-volt systems like the windows and the screens, and it moves them outside of the motor housing.
And honestly, it is a brilliant move for long-term ownership.
Why is that?
Well, in a lot of early EVs, if the DC-DT converter failed, a technician might have to drop the entire motor and axle assembly just to access the part.
Oh man, that sounds expensive.
Very expensive. So centralizing them into the IPB reduces overall vehicle weight, frees up space, and really slashes the labor hours required for any out-of-warranty repairs down the road.
Okay, so let's talk about how far all this tech actually gets you. Because bridging the gap between an engineering brochure and real-world driving is critical.
Always.
Let's look at the WLTP range first. That stands for the Worldwide Harmonized Light Vehicle Test Procedure. It's the standardized laboratory test every car sold in Europe has to pass.
Right, and it's highly controlled. Ambient temperatures of 23 degrees Celsius, no air conditioning running, very specific acceleration curves.
Perfect conditions, basically.
Yeah.
And under those conditions, the Q6 e-tron scores up to 625 kilometers for the Quattro and 641 kilometers for the rear-wheel drive performance model.
But, driving on a laboratory dyno is very, very different from driving in the real world.
Yeah, WLTP numbers are like running on a laboratory treadmill, but real-world range is like running outside in the wind and hills.
That's a perfect analogy. You have aerodynamic drag, freezing temperatures, a cabin full of passengers. It all takes a toll.
Exactly. Which is why the data from Pool Audi is just so valuable to look at here. They tracked actual owner feedback from UK roads.
And what did they find?
So for the larger 100 kilowatt-hour battery, owners are reporting a very reliable real-world range of 275 to 300 miles. That's roughly 440 to 480 kilometers. And for the smaller battery variant, they are seeing about 225 to 240 miles per charge.
That is a highly respectable yield, particularly given the size and the weight of this vehicle.
Yeah, they noted a real-world efficiency metric of roughly 3.0 miles per kilowatt hour.
But we should note that efficiency is heavily dependent on the physical choices the driver makes, right?
Oh, definitely. Like, if you opt for the massive 20-inch sport wheels, the physics of rolling resistance pretty much guarantees your efficiency will drop compared to smaller, narrower tires.
Right. And terrain and climate control also draw significant power. Heating a large, cold cabin in the dead of winter is honestly one of the most energy-intensive things an EV has to do.
But the sources do provide some concrete mitigation strategies, right? Tips for you to optimize that 300-mile range.
Yes, absolutely. Knowing these real-world numbers is empowering, and there are ways to stretch them.
Like preconditioning. That seems to be the most impactful tip they mention.
Oh, preconditioning is huge. While the car is still plugged into your house, you use the app to warm up the battery and the cabin.
So you're pulling power from the grid to heat the car, rather than draining your battery's range just to defrost the windshield on a freezing Tuesday morning.
Exactly. They also emphasize charging best practices. For daily commuting, setting the car's software to stop charging at 80% significantly reduces the degradation of the battery chemistry over the entire lifespan of the vehicle.
Right, you really only charge to 100% when you are actually departing on a long-distance trip.
Yep. Furthermore, utilizing the one-pedal regenerative braking allows the motors to run in reverse. It captures kinetic energy and feeds it right back into the battery every time you lift off the accelerator.
Instead of just wasting that energy as heat on the brake pads.
Exactly. It replaces range anxiety with predictable charging convenience once you get the hang of it.
Okay, so range and charging dictate how you navigate the outside world. But what is it actually like to sit inside the cabin during those 300 miles?
Audi calls their interior overhaul the digital stage.
The digital stage, I like that.
Yeah, and the overarching interior philosophy is called soft wrap. The designers intentionally use these premium textured materials that extend continuously from the doors all the way across the dashboard.
So it's not just hard plastic everywhere.
No, the intent is to counteract that cold, clinical feel that heavy instrumentation can sometimes create. They opted instead for a warm, enveloping ambiance.
But make no mistake, there is a massive amount of instrumentation in here.
Oh, for sure.
I mean, you cannot miss the triple display setup. You have the 11.9-inch Audi virtual cockpit directly in front of the driver, which kind of flows into a 14.5-inch curved touchscreen in the center.
But the wild card is that third screen.
The 10.9-inch passenger display. And this isn't just a mirrored screen. It features active privacy technology.
Yeah, the privacy tech is a fascinating functional addition. The screen actually has a directional polarizing layer.
So what does that mean in practice?
It means the passenger can be watching a full-screen movie or browsing the internet, and from the driver's seat, the display appears completely dark.
Wait, really?
Yes. It actively prevents moving imagery from catching the driver's peripheral vision.
So what does this all mean? My passenger can be binge watching a reality show while I'm white-knuckling it through a blizzard and I won't even know.
Basically, yeah.
But it does make you wonder, with a dedicated private screen for the passenger, are they just isolated in their own digital bubble? Or does this actually enhance the road trip for everyone?
Well, from a safety and operational standpoint, it dramatically reduces the cognitive load on the driver
How so?
because the passenger can assume the role of the navigator. They can search for charging stations, adjust the route, or manage the media without ever needing to lean over and obscure the driver's view of the central screen. The technology is designed to manage distractions while heightening spatial awareness.
That makes sense. I will say, though, a potential downside to all these screens is the learning curve. Moving tactile controls, like your climate adjustments, into a touchscreen menu requires taking your eyes off the road, even if it's only for a second.
Which is something physical buttons never demanded.
Right.
And that is a very valid critique of modern automotive design.
Right.
But Audi attempts to mitigate that distraction through advanced voice controls and the augmented reality head-up display.
The AR head-up display is wild. I mean, it doesn't just project your speed onto the bottom of the windshield like older systems.
No, it goes way beyond that.
It projects active navigation arrows that appear to float like 10 meters down the road directly in your line of sight, dynamically pointing you to your exit lane.
It's incredible. And the entire infotainment system runs on Android Automotive OS.
And to be clear, this is not just Android Auto mirroring your phone, right?
This is the actual brain of the car. It allows for seamless over-the-air or OTA updates. So the braking algorithms or the battery thermal management software can literally be improved by Audi 2 years after you buy the car.
Which is just a totally different way of owning a vehicle, but the digital stage isn't confined to the interior, is it?
No, they have externalized this technology with the active digital light signature.
Ah, yes. The rear taillights utilizing second-generation OLED panels. We have to talk about this because this is where aesthetics really cross over into infrastructure.
Yes, exactly.
Yes, you can choose from 8 different light signatures to make the back of your car look cool, but the actual innovation here is vehicle to everything, or V2X communication.
Right.
If the Q6 e-tron sensors detect an emergency braking situation or an accident ahead or even just the tail end of a traffic jam, the OLED panels instantly project a specific warning triangle symbol.
To visually alert the cars behind you.
Yeah.
It acts as an early warning system for the surrounding traffic. It's a proactive approach to safety, really trying to prevent rear-end collisions before the driver behind you even realizes there is a hazard.
I do wince a little thinking about the replacement cost if you actually do get rear-ended and have to replace an intelligent OLED V2X taillight array.
Oh yeah, that won't be cheap.
But those warning lights bring us to our final and arguably most critical point, occupant protection. Because if the proactive warnings fail and an impact is inevitable, what actually happens?
Well, the safety metrics from independent testing are formidable. The European Consumer Protection Organization, Euro NCAP, awarded the Q6 e-tron their maximum 5-star rating.
Nice.
But the specific breakdown is what really matters here. It scored 91% for adult occupant protection and a massive 92% for child safety.
92%. That makes it best in class for all vehicles tested by Euro NCAP across 2023 and 2024.
It's incredible.
And when you look at the source data, that isn't a fluke. Audi employs 220 safety experts who conduct over 1,000 physical crash tests and 20,000 virtual simulations every single year.
And the physical hardware in the cabin really reflects that rigorous testing. The vehicle is equipped with 3 eye-size compatible seating positions.
Okay, break that down for us.
So there are 2 in the rear and, crucially, 1 in the front passenger seat. Eye-size is a very stringent European safety standard that guarantees a secure, standardized fit between the car's anchor points and modern child restraints.
And the front passenger seat has a feature that is, honestly, genuinely remarkable. If you're a parent, a car that virtually comprehends when to turn off an airbag isn't just a cool feature that is profound peace of mind.
Oh, absolutely.
Because if you install a rear-facing child seat in that front passenger position, the Q6 e-tron utilizes weight and pressure sensors to automatically deactivate the front airbag.
Yeah.
You don't have to remember to stick your car key into a slot in the glove box or navigate through 3 sub-menus on the touchscreen. The car just senses the child seat and disables the explosive charge entirely on its own.
This raises an important question, though, about how the definition of automotive luxury has shifted.
What do you mean?
Well, historically, a premium vehicle was defined by, like, the quality of the leather or the acoustic dampening in the cabin.
Right, mere comfort.
Exactly. But today, luxury is intelligent, proactive safety. It is a vehicle that literally configures its own safety restraints based on who is sitting in the seat.
That is a great point. And the Euro NCAP report also highlighted the newly evaluated post-crash functions.
Right, because the safety loop doesn't end after the impact.
Exactly. If the worst does happen, the car has an e-call system to automatically ping emergency services with your exact location.
Which is vital.
And it also actively provides digital rescue data sheets to first responders. So when the fire department arrives with the jaws of life, the car tells them exactly where the 800-volt battery cables are.
So they know exactly where it is safe to cut the frame without risking electrocution. It's a comprehensive safety loop. You avoid the crash using the V2X OLED warnings, you survive the crash utilizing the structural rigidity of the PPE platform and the smart airbags, and then you facilitate an immediate, safe extraction utilizing the digital rescue sheets.
Wow! So what does this all mean when we put the pieces together? The Audi Q6 e-tron utilizes its bespoke PPE platform and that 800-volt architecture to deliver a zero-compromise blend of high-speed charging, real-world utility, inviting digital design, and class-leading safety.
It clearly demonstrates the engineering advantages of just abandoning legacy ICE platforms and committing fully to a native electric architecture from the ground up.
Which leaves us with a fascinating thought to chew on. If our vehicles are now utilizing sensors to automatically comprehend whether a child or an adult is in the passenger seat, and they are using exterior OLEDs to actively communicate invisible hazards to the cars around us, at what point does a car stop being just a passive tool you drive and start becoming an active, intelligent co-pilot that watches your back?
It's definitely something to consider the next time you slide behind the wheel.
Absolutely. Well, we want to sincerely thank you for spending your time and taking this deep dive with us today. We know your time is incredibly valuable, and we appreciate you spending it with us exploring the cutting edge of the road ahead. Until next time.